Quick note to our listeners, we need your help. We're close to 1 million views on YouTube, and we have over 5,000 subscribers. But if we can get to 10,000 subscribers by the end of this year, that will allow us to raise money for the Finding Genius Foundation and our study to help those suffering from anxiety, depression, and PTSD. Please just take a second and subscribe to the podcast. And if you can, like the video. That'll help us get more listeners. It'll help with the YouTube algorithm. And again, help us reach our goal of 10,000 subscribers and 1 million views. We're going to hit the 1 million views, it looks like, hopefully by May of 2022. But the 10,000 subscribers will be harder. That's going to take until the end of this year. Thank you.
Do you struggle with concentration? Have you ever thought of your brain health long term? Bowmar Nutrition is revolutionizing the nootropic and cognitive health industry with Sharp Nootropic Powder and patent-pending Bright Daily Capsules, powered by NeuroBloom. If you struggle with focusing, think of Sharp as brain food that supports concentration. Sharp works with your natural brain chemistry to provide a heightened sense of well-being that can delay cognitive decline and also increase mood. Bowmar Sharp tastes amazing and comes in many different flavors, available in caffeinated and non-caffeinated versions. While Sharp is a short-term aid in cognitive health, think of Bright Daily Capsules as a way to improve overall brain health and prevent cognitive decline long-term. As we age, so does our brain. Supplementing with Bright has the potential to delay this aging process and helps your brain function optimally. Stay ahead of the curve and order yours today at bowmarnutrition.com and save $5 off with code GENIUS5.
Forget frequently asked questions,
common sense, common knowledge, or Google.
How about advice from a real genius? 95% of people in any profession are good enough to be qualified and licensed. 5%
go above and beyond.
They become very good at what they do, but only
0.1%
are real geniuses. Richard Jacobs has made it his life's mission to find them for you. He hunts down and interviews geniuses in every field: sleep science, cancer, stem cells, ketogenic diets, and more. Here come the geniuses. This is the Finding Genius Podcast
with Richard Jacobs.
Hello, this is Richard Jacobs, the Finding Genius Podcast, now part of the Finding Genius Foundation. I have Jason Kindrachuk, PhD. He's an assistant professor. He holds the Canadian Research Chair in Molecular Pathogenesis of Emerging and Re-emerging Viruses. He's part of the Department of Medical Microbiology and Infectious Diseases, all this at University of Manitoba. So, Jason, thanks for coming back.
Hey, thanks for having me on.
If you would tell listeners about your research, what are you focused on?
Yeah, so most of what I'm focused on, really in a nutshell, is the circulation, transmission, and pathogenesis of emerging viruses, which really means, where are these viruses hiding in nature? Why and how do they spill over from their wild animal reservoirs into humans or in other animals? And what happens when they get there? It's complex. It's, there's molecular virology, there's clinical aspects, there's obviously social science aspects and conservational aspects, but it's really what we do and kind of, what I enjoy doing.
Well, what are you focused on? A particular virus or pathogen?
There's a few things, right? So listen, Ebola virus is what got me into this game in the first place, way back when Hot Zone came out, and then an Outbreak came out on VHS. For those that remember VHS systems, still, that kind of pulled me in. I think it was that this impression that there are these viruses in nature that can have case fatality rates of 50% or more, and can wipe out whole communities in short periods of time. It was really this kind of epiphany that, I lead a very sheltered life in not realizing the impacts of infectious disease. So Ebola has and always will be a focal point of what we do. We in particular are very, very interested in this idea of persistence, this idea of long-term persistence of the virus in patients that recover. We see certainly in male patients, up to 50% of male patients are, at least from modeling, are believed to still harbor infectious virus up to 4 months post-recovery within their reproductive tract. That's concerning for us from a containment standpoint, from certainly a clinical and human health aspect of trying to curb transmission. We've seen now virus has moved from people that had no idea that they were still infected into their loved ones or into their community, even years following their recovery. So we're trying to understand why that happens, how it happens, and what we need to provide for these survivors of the long term. What are the long-term health consequences of these persistent infections, and what are the long-term health impacts we see in people that recover? So we're focused on trying to understand where the virus is in nature that still is I think a big question for us, we've moved into COVID research looking at, I think, every aspect imaginable, primarily focusing right now on different animal species beyond humans. That are harboring SARS-CoV-2. So where has this virus gone into in wildlife? What is the potential for spillback from wildlife into humans? What does viral evolution look like in these animals? And then, of course, we take on, every other emerging virus that kind of gets thrown at us. So, influenza is always on the periphery. We're certainly, I think, gearing up to try and help out with what's going on with H5 right now and its movement across the globe. So we're focused on one virus with Ebola primarily, but we take on pretty much everything we can from an interest and a public health standpoint.
Well, let's talk about Ebola. But I guess first a generic question. Beyond what are commonly known as retroviruses, have you seen any viruses that are able to endogenize into any animal or person's DNA that is not a retrovirus? For our work, we haven't, right? And this has been this complicated question right now with Ebola virus in regards to persistence. We and others have shown that in cell culture. So in the lab, we can get long-term infections of, weeks to months in cells with Ebola virus, where the virus does not wipe the cells out, which is, it happens in a subset of cells. It doesn't happen in every cell type. And it starts to say, we'll give you some influence and kind of interest in the fact that, this can happen. But the longer term question is, okay, so that happens in weeks to maybe a couple of months when you're working in a very isolated system. Now we're looking at patients where you're looking at persistence in months to years. That's a much broader question of how is it doing this? I think that we have a number of theories. RNA viruses, certainly negative sense RNA viruses that, don't have the ability to integrate. It's likely not latency. It's not integration, but we don't fully understand what's going on. So a lot of questions to be answered. It sounds like these viruses are going into, a latent period where the person doesn't experience symptoms, but the virus is still hanging out there. And then does there have to be a triggering event where the person gets sick and then they spread it? Or do some people seem to be able to spread it even when a virus, again, appears to be latent and they're asymptomatic?
This is such a great question, right? And certainly something that we're trying to get a little bit of spotlight on with the work that we're doing with survivors. So what happens? What does this persistent infection look like? And why do we see, months to years where there's no transmission and then suddenly there is a transmission event? I don't think we fully know. I think part of it is, certainly in the shorter time frame, we know right now the recommendations from World Health Organization and others, are very much heavily in regards to sexual transmission for survivors. So this idea of using different types of protections to be able to try to reduce viral transmission. That's certainly important. The question, though, when we start looking at years is really what has happened? Has there been some sort of, a stress event or an immunological event that has led to the release? Now, the thing we can say with our patients, but with these survivors that have the persistent infections, is that if you do a traditional blood diagnostic, they're negative, okay? So even though they're harboring massive amounts of virus in their semen, we don't see any sort of spillover of virus, at least that's detected back across the blood-testis barrier. So it looks like, at the very least, the virus gets into the testes. It doesn't seem to be leaking back out. So now we get into this question of saying, okay, well, it's probably not a stress event that is leading to, recrudescence, kind of like what we've seen with the Scottish nurse who had virus in her central nervous system. And then we saw recrudescence and the virus came back out and she was positive by blood diagnostic and was viremic. We don't see these with these patients. So it's probably not a stress event, but then it's a question of, is the overall amount of virus, do we see that it kind of plateaus or that there's a persistent phase and then it drops off? Does it go through ebbs and flows? I think those are the bigger questions we don't know. Certainly in the months time frame, it looks like, listen, we get to a peak when we're able to start assessing semen from patients, and it slowly goes down to the limit of detection over the span of a few months. In the year time or the multiple years time frame, we don't know, and I think that's going to be really important, certainly for the work that Pierre Fermente and others from WHO and across Central and West Africa that they're doing in assessing cohorts of patients over the long term period. We certainly want to look at the same.
If you have latency of months or even years, and even any latency, how do you know that it's attributable to a certain person?
this is the big thing with Ebola virus, right? Is that the mutation rate and the evolutionary rate appears to slow down when it gets into the testes. And so one of the things we've been able to do is actually use sequencing to be able to look to match up people, when we see new outbreaks, whether or not there is a relationship back to a prior circulating virus. And then we can start to put things together and say, okay, where, who was positive, what, was the mode of epidemiological transmission. So that has actually helped us in this regard, is that we have this slower evolutionary rate for Ebola virus in this situation. Doesn't transfer over to all other RNA viruses. But at the very least, what we can now do is look at outbreaks and say, okay, is this attributable to a potential persistent infection, or does it look to be something that is new, that was not identified in a prior outbreak, and thus likely relates to a new spillover? Kind of what we're seeing right now in the DRC in their latest outbreak, which was sequencing results within days said, listen, this looks like this is a brand new spillover and not from a persistent infection.
So you're looking at semen, so I guess you're only looking at men, but why semen? Why not look at blood and, maybe sweat, breath, etc.?
Yeah.
To get a complete profile. Maybe the latency is not showing up in semen, but showing up more in blood or breath.
Yeah, it's a great question, right? And certainly this is something that, way back in, kind of my prior days when I was still at NIH, we had a patient that was cared for at the Special Clinical Studies Unit that was a U.S. healthcare worker, got infected in Sierra Leone, and we ultimately, our department, critical care medicine, was able to provide him care and got him through to his recovery. One of the things we were able to do was we had a clinical protocol to be able to get biological samples from that patient longitudinally throughout his illness. Problem was, obviously, you can't get semen from a patient that is in critical condition, but we were able to get things like blood, sweat, urine, feces, other materials to be able to look at this. Now, when we look at those rates, and certainly not only us but others, we don't see that same rate of persistence, right? We get into this area of saying, okay, where are the immune privileged niches within the immune privileged areas within an organism or within a person where we would likely see persistence? Central nervous system, certainly the reproductive tract within males, and obviously the eyes have been another region. And then can we start to look at persistence? So there are groups that are looking at central nervous system, certainly groups that have been doing this with non-human primates, from looking at historical samples. We've been doing it from semen because that's one of the, our concerns from a containment aspect and outbreak standpoint is we have patients that are positive that don't necessarily know that they're positive unless they get their semen tested. So we need to be able to try and figure out all of the pieces of this puzzle to be able to provide, I think, better supportive care and recommendations.
Do we have people that are, again, they'll get Ebola, they won't, you test them, and then they're forever fine, or at some point they all of a sudden get sick?
Well, so that's the thing with the persistent infections at least with reproductive tract. We haven't seen these patients show any signs of or physiological symptoms of disease. So you have patients that have, for long periods of time, have these reproductive tract infections that are persistent, but in the absence of any physiological symptoms of disease. And if you test them by blood diagnostic, they're negative. So you have patients that have no idea that they are infected. And right now, our only diagnostic method to be able to find out if they have virus within the reproductive tract is by assessing semen, which becomes a bigger issue in terms of trying to get patients that will provide semen samples. How do you do this? And certainly in the field, it is not easy.
Well, how do people tend to first experience Ebola typically? Do they get it from, respiratory droplets, or do they get it from, consuming bushmeat? Like, what's the predominant way you identified?
Yeah, great question. So when we look at Ebola infections in general, the majority of these are happening between, from contact with infected animals. And this can be through a couple sources, right? One is we think bats and fruit bats in particular are the reservoir species for this virus. So direct contact with humans and bats, whether it's with the bats in regards to their biological fluids or if there's any sort of a bite, we think that can likely lead to transmission. Though I have to say we still have not been able to recover infectious Ebola virus from a bat. So our understanding of what that transmission chain looks like is certainly somewhat cloudy. But we also know that bats interact with a number of other animals, some of these of which are non-human primates. And we know that animals like gorillas and chimpanzees can be infected in the wild by Ebola viruses and have a very similar overall clinical picture to what humans do. Well, we know that humans obviously hunt some of these types of animals from non-human primates as wild game in different areas of the world. If you put those people in contact and you have the potential for somebody with small cuts on their skin abrasions, they're cleaning meat and they have exposure to blood that has high amounts of virus, that's a potential route of exposure. Or if it's able to transfer into their mouth or their eyes or their nose through those mucous membranes, there is your index case. Once you have that index case in the first human, then human-to-human transmission can start to occur through close contact, mostly through contaminated fluids. So things like vomit, diarrhea, blood, these samples we know are laden with Ebola virus. And of course, when people are sick, so when they vomit or when they have diarrhea, if you're in close contact, as that fluid is coming out, there's dissemination of droplets and probably some even aerosols in very, very short distance that likely have virus. So people that are in close contact, as long as they have exposure through their mucous membranes or through abrasions on their skin, they can potentially get infected. And then, of course, sex appears to be linked to this as well, though we're still, I think, a little bit behind the eight ball in understanding what that looks like.
Are there, I wonder if there's two kinds of latency. Like, if I get exposed to flu, the latency could be because the virus is replicating and building up to the point where now it's ready to, really cause me problems and make me sick. But it seems like there's other kinds of latency where the virus, will go quiet for weeks, months, years, and there's probably some signaling or maybe, I don't know, some kind of quorum sensing of maybe infected cells that aren't actively infected. And the virus says, all right, at this point, we're ready to make a move again and attack. So have you observed that there's two kinds of latency? Or have you gone deeply into latency and how it works, or has anyone?
Yeah, so there's a couple things, right? So the first thing with Ebola, certainly when we think about infections, people that are infected, as we're going through that pre-symptomatic period, virus is building up. It's moving out through their blood system, so it moves into their lymph nodes first, through their immune cells, and starts to disperse around the body. They are not able to transmit virus up until the point that they become symptomatic. I guess one of the saving graces for us with Ebola is that patients will not be able to transmit until they're symptomatic. So from a containment standpoint, we're not dealing with the same situation we're dealing with right now with COVID or even with influenza, where you can have this pre-symptomatic transmission and then it's much more difficult to get things contained. Your other question, though, in regards to this persistence aspect is certainly something we're focused on. So when we think about the reproductive tract, where our work focuses specifically on the blood testis barrier in the males, the virus appears to be able to move into the testes through the blood testis barrier, which functions kind of like a dam, kind of like we see in the central nervous system with the blood-brain barrier. So what this does is it restricts immune cells from being able to move into the testes, because this is where our sperm is maturing, and obviously we don't want to have autoimmune reactions against our gametes. So the virus gets into there. What we see then, at least in our work, and looking directly at some of these blood testis barrier cells, is that the virus is able to replicate, and actually replicate, at least in cell culture, to fairly high titer and fairly high amounts. But the cells don't have this really strong kind of apoptotic cell death response. The cells actually seem to be quite okay with it. So they're not mounting massive inflammatory response. They're probably suppressing replication just enough so that the cells don't get triggered into apoptosis, but not enough to actually completely quell the virus from being able to replicate. So then the virus is just spilling over into sperm, into seminal fluid, and then moving out through sexual contact. So it's difficult because we have this phenomenon where the virus gets into the testes. We don't think it's moving back out across the testes, back into blood system, into the interstitial spaces where it can start to disseminate across, throughout the person. But we don't necessarily know what's happening at that barrier. Is it that you have enough of an immune response that even if virus spills out, it doesn't actually result in viremia, or is the virus actually just not even spilling out whatsoever? So there's no pathology or disruption of the blood testis barrier. And I would say right now our data suggests, at least for Ebola virus, the latter.
Okay. I've heard, I guess, with Ebola that no one really knows what the reservoirs are in the wild where it comes from. Is that the case? And how close have you gotten to figuring out where it comes from and where it goes? When it's,
yeah, this is Man, this is the 45-year-old or 46-year-old question now of, where is Ebola hiding and how do we figure out, what it's doing in the wild? I will go back to saying we have not recovered infectious Ebola virus from a bat at this point, or from a fruit bat. And that's, taking into account decades of research doing surveillance within fruit bats and taking samples and looking for it. Now, there's a couple things to keep in mind here. One is, first of all, for Marburg virus, which is, Ebola's, I think, bigger, badder brother in many ways, Marburg virus has been recovered from bats. So that starts to tell us that, okay, filoviruses, the family of filoviruses looks like it actually is utilizing fruit bats as reservoirs. And by the way, we've seen Yovio virus, which is another newer filovirus recently identified in bats from Hungary. So the tail of the tape would say for philos, likely fruit bats. Well, for Ebola, we've also found fragments of genome. So not the whole genome yet, but at least fragments, which suggest the virus was there. But we've also seen serologically that bats also will produce antibodies against the virus. So again, the virus was there. They were exposed. We don't know what infection looks like, but all the data leads us to saying, okay, likely that bats are the reservoir. Are there other incidental hosts beyond, or intermediate hosts beyond those we've identified? That's still a question. But I think all the data tends to lead us in one direction. And then if you look at the outbreaks across Central and West Africa, and then you overlay fruit bat migratory patterns, you get this really nice picture of specific fruit bat species that appear to overlay almost, I wouldn't say perfectly, but very plausibly with, again, if you look at those migratory patterns for fruit bats and you overlay the migratory patterns for different species of fruit bats over top of outbreaks that have occurred across Central Africa and obviously the West African epidemic, you get this picture. Specific fruit bat species whose migratory patterns overlay very plausibly with these outbreaks. So not only does our molecular evidence tell us that fruit bats are the likely reservoir, even the migratory patterns highly suggest that this is likely the case.
So you do think it comes from bats, bats that would bite people, or bats that would bite cattle, or bats that would bite monkeys, or what do you think?
Yeah, it gets so complicated, right? Because it certainly, when we start to think about this from a, say a conservation aspect or an ecological aspect, we have to start to think about, okay, well, what is driving these events of transmission? Because first of all, not every fruit bat or every species of a particular fruit bat are infected at any one period of time. So you have this tiny fraction of bats that are probably infected and actually have replicating virus. Then you have to start to look at things like seasonal patterns. So when are animals going to be in close proximity to one another? So if we know that, great apes, different non-human primates, even dukers, which are these small deer in Central Africa, these animals have shown positivity for Ebola virus. Well, when are those animals likely in close proximity to bats? Well, it looks like during the wet season, not so much. There's a lot of fruit and a lot of food for these animals, but in the dry season, there probably is a greater likelihood that these animals are foraging at the same location. So not only do you get circulation within bats and an increased circulation just through contact and fighting and biting and reproduction, but you probably also get transmission events, whether it's through droppings, whether it's through biting, whether it's through contaminated fruit. We don't know, but the likelihood starts to get us back into this triangle of saying, okay, bats, other intermediate hosts or incidental hosts, and then we add in humans, and the likely contact pattern is probably with both bats as well as the infected animals.
Thank you very much, Jason Kindrachuk, for coming on the podcast. It's a very interesting issue. For some reason, I think it's very fascinating. I hope listeners will think so as well. So thank you both.
Do you struggle with concentration? Have you ever thought of your brain health long term? Bowmar Nutrition is revolutionizing the nootropic and cognitive health industry with sharp nootropic powder and patent-pending bright daily capsules, powered by NeuroBloom. If you struggle with focusing, think of Sharp as brain food that supports concentration. Sharp works with your natural brain chemistry to provide a heightened sense of well-being that can delay cognitive decline and also increase mood. Bowmar Sharp tastes amazing and comes in many different flavors, available in caffeinated and non-caffeinated versions. While Sharp is a short-term aid in cognitive health, think of Bright Daily Capsules as a way to improve overall brain health and prevent cognitive decline long-term. As we age, so does our brain. Supplementing with Bright has the potential to delay this aging process and helps your brain function optimally. Stay ahead of the curve and order yours today at bowmarnutrition.com and save $5 off with code GENIUS5.
You've been listening to the Finding Genius podcast with Richard Jacobs. If you like what you hear, be sure to review and subscribe to the Finding Genius podcast on iTunes or wherever you listen to podcasts. And want to be smarter than everybody else? Become a premium member at findinggeniuspodcast.com. This podcast is for information only. No advice of any kind is being given. Any action you take or don't take as a result of listening is your sole responsibility. Consult professionals when advice is needed.